Students, in our previous class, we have seen something about alternating current and direct current, isn't it? So, alternating current and direct current we have seen in our previous class. So, here we will see the things in detail. So, coming to direct current, DC. Okay, so we present as what? DC. So, what is direct current? So, a current whose direction and magnitude, or we have current which is flowing in one direction and its magnitude remains constant. A current which flows only in one direction and its magnitude remains constant, such current is called as what? Direct current. Okay, so the current which flows in only one direction and its magnitude remains constant with respect to time is called as what? Direct current, or DC we call it as. Okay, direct current. Okay, so this is how we will be representing the direct current. It does like we have y-axis voltage representation and x-axis we have what? Time, direction, and so much of time we have actually flowing in this scale we will be going for time duration, and here we can see the voltage remaining what, or current remaining what? Constant with respect to time. Here it is, for this time it is same magnitude, here again same magnitude, same magnitude, same magnitude, same magnitude. So magnitude being what? Strength of the source. Okay, so this is what is what? Direct current. Coming to alternating current. So alternating current means what? So alternating current is some current whose magnitude and direction, whose magnitude is continuously changing and direction is also continuously changing. Okay, so sometimes it is positive, sometimes it is negative. Okay, so if I have to go for this thing, this side we have all positive values, this side we have all negative values, isn't it? So for some current or voltage source, or some current which flows or which is flowing, okay, so we have alternating current wherein we have the magnitude and direction. Both magnitude and direction are continuously or periodically changing with respect to time. Okay, such current is called what? Alternating current. Okay, the current whose magnitude and direction are continuously or periodically changing with respect to time, such current is called as what? Alternating current. So AC will call it as. So we will represent your alternating current in terms of what? Sine wave. So this is how it looks. Okay, so with respect to time, here we have taken in this direction, we have taken voltage thing, and this is how it is flowing. Okay, so now here we can see. So this is all like different values we have, and we have different values which are continuously changing, and also the direction is changing. Sometimes it is positive. From here to here it is positive. From here to here it is negative. Okay, so this is positive half. This is negative half of your alternating current, we can say it as. Okay, so this is how we have alternating current, and then we have a direct current, and then we have a alternating current. Okay, fine. Yes. So after all this, so we will be considering another thing called as what? For an alternating current, I will be going for something called as what? Frequency. What is frequency? What is frequency? Have you ever heard of frequency? Yes, you have come across this in your school, isn't it? Frequency, denoted as what? F. So, frequency denoted as what? F. Okay, so what is frequency? What is frequency? When it comes to an alternating current, so before learning about frequency, we have to come to a point called as what? Cycle. What is cycle? What is cycle? For an alternating quantity, what we have here, for an alternating quantity, so cycle is something. So here, if I have to go for this, so this is being. So here, the representation or your current starts from here, it goes to positive maximum value and it it comes back to 0, and from 0 it goes to negative maximum value, and it goes back to what? 0 here. So started from here, ended here. So this complete thing, one positive direction flow, one negative direction flow, together will make what? One cycle. Okay, so this is how we will be going for one cycle for an alternating quantity. One cycle is what? It is one positive half cycle plus one negative half cycle. So this duration or this part of your alternating wave representation is called as what? One cycle. Okay, one positive half cycle plus one negative half cycle will make what? One cycle, one complete cycle we call it as. Here it will be, what is this? From here to here angle will be 180 degrees, isn't it? This will be 90 degrees, this is 270 degrees, and this is what? 360 degree, isn't it? So likewise we have one complete cycle. So one complete cycle we have from here to here, and this is what is what? One cycle, or we can say cycle. Okay, cycle of an alternating quantity, we can say it as. So this is one cycle. And what is frequency? Frequency is a measure of what? Number of cycles per second. Okay, so this in this direction we have time, isn't it? So for 1 second of time, how many cycles have come? So in 1 second of time, how many cycles have come? So that measurement is all about what? Frequency. So frequency is what? Number of cycles per second. In 1 second, how many cycles are coming into picture? So that says about what? Frequency. Fine? Is that okay? Yes. Number of cycles per second is called as what? Frequency. So here, if I have to say for an alternating quantity, listen, and frequency is measured in terms of what? Hertz. Hertz is the unit for frequency measurement, and this written in short as what? XZ. Hertz. Okay, fine? Yes. Now let me see. For an alternating quantity, I will make some example here. So for this alternating quantity, I have, so like this. Here will be here is will add up. Okay, so here let us see. Let me take this duration as what? Up to here. Okay, fine. If I say this is 1 second of time. Okay, this is with respect to time, isn't it? Yes. So this is your representation or current representation. Here is your 0, 1. Okay. So this duration is what? 1 second. So what will say how many cycles have come in 1 second? So from here to here it is 1 second. Okay. So our frequency is measurement of number of cycles in 1 second, isn't it? Yes. So how many cycles have come here? So this is first cycle. This is second cycle. This is third cycle. So we have 1, 2, 3. We have 3 cycles for this example what I have drawn here. So in 1 second of time, 3 cycles have come. So I can write the frequency as what? 3 Hertz. For this example, the frequency of this particular representation is what? 3 Hertz, because in 1 second of time, 3 cycles of alternating quantity have come. So I can say it as what? 3 Hertz of frequency. Is that okay? Fine. So this is how I can say about frequency. Frequency is nothing but what? Number of cycles, number of alternating quantity or alternating current cycles in 1 second of time. So this is how I will be calculating the frequency. So frequency. And about cycle we have learned, about frequency we have learned. We have learned about the unit for representing your frequency. Okay. So after all this, I will be taking another thing. Now, I take another thing now. Okay. So about your alternating quantity itself. Okay, fine. Yes. So this is. I have represented only one cycle here. Okay. So now I have represented an alternating quantity example where I have represented only one cycle. Okay. So here the cycle starts and here it ends. So this is what? One cycle. Okay, so this direction is tan, this direction will have this magnitude, isn't it? Yes. Here, now the time taken. Now the time taken for one cycle. So the first cycle started here, it has ended here at this time. It has started at 0th time and it has ended at this particular time, isn't it? A particular time interval. So it has taken some time for this one cycle to happen, isn't it? So now time taken for one cycle. So time taken for making one cycle of alternating current is called as what? Time period T. What is this? Another thing has come into picture now. It is called what? Time period. What is time period? It is the time taken for making one cycle. So the time taken for one cycle of an alternating quantity is called as what? Time period T. Okay, and it is measured in what? Seconds. Obviously, in seconds only we will be measuring it. So time period is nothing but time taken for one complete cycle. So one positive half cycle, one negative half cycle for an alternating quantity. So this is complete cycle, and this cycle, this is half part of your cycle. This is, we will call it as what? Positive half cycle. We will call it as. And this is negative half cycle. This is positive. This is negative half cycle. This is positive half cycle. Both together will make what? One complete cycle. And time taken for one complete cycle is called as what? Time period. It is denoted as what? Capital T, and it is measured in what? Seconds. Fine. So this is one cycle. Time taken for one cycle is time period. Number of cycles per second is called as frequency. And this is your positive half cycle. This is your negative half cycle. This is how your alternating current will change its direction from positive to negative, negative to positive. Likewise, we will have the continuous change in periodical change in magnitude and direction of an alternating quantity. Will make so many things coming into picture. And when it comes to DC, is there any frequency? No, isn't it? For DC, we have the DC current is something which flows in only one direction, and there is no change in the magnitude, isn't it? And it flows in only one direction. That means what? There is no question of frequency, isn't it? There won't be any variation. There won't be any change in direction. So there is no positive negative kind of things, isn't it? So such currents are what? DC currents, where in the magnitude and direction remains constant. So this is how we can say the direct current as. So for direct current, we can say there is no frequency at all. Okay. So DC currents won't have any frequency. So ACs will have certain frequency. Okay. So this is how we can make out for your frequency term, which is there for your alternating quantity. So only for alternating current we have the thing called as frequency. Very important. Okay. So now coming to comparison or differences between your DC and AC. Okay. So comparison also we can say it as, or differences. Comparison in the sense we are comparing DC and AC. Also we can say it as what differences between your AC and DC also. Okay. So this direction I have taken direct current. Here I have mentioned alternating current. Okay, fine. So we will be going through all of the points, and we will think this is very easy to, isn't it? We know about AC and DC. We can write the differences or comparison. Okay, we write. Okay, so we will start with the first point. So DC source symbol. DC source symbol in the sense DC voltage source or current source, or we can say DC source, direct current source representation. Circuit symbol representation is somewhat like this, isn't it? So we will write in terms of two of the lines, larger line, smaller line. Larger line is for positive and smaller line is for negative or ground connection. Okay. So this is how we will be representing the DC source. Okay. When it comes to AC source symbol, AC source symbol means alternating current source symbol will be represented in somewhat like this way. So this is what a circle, and we will represent an alternating thing inside the circle, so that it will represent us. This is what an AC circuit symbol. We can say it as, here we are not mentioning any positive and negative polarities. Why? Because alternating current continuously changes its direction. Okay, so polarity will be changed for each and every half cycle. Okay, so this is how we will be going for AC source symbol representation. This is your DC source symbol representation. Okay, so coming to DC direct current. Second point, direct current remains constant with respect to time. Direct current remains constant with respect to time. Isn't it? Fine. So direct current remains constant with respect to time. So alternating current varies periodically. Okay, alternating current varies periodically with respect to time. So we know that too, isn't it? So direct current remains constant with respect to time. Alternating current continuously changes its magnitude with respect to time, isn't it? So that is in the second point. Okay. So the third point is what? DC has no frequency. Right now we have seen, isn't it? DC has got no frequency because there is no change in the direction of the alternating quantity. Okay. Yes. Coming to AC, it has got certain frequency, isn't it? So AC or alternating current will have certain frequency. Okay, for definite. Okay. Yes. So coming to fourth point, while transmitting your DC. So transmitting DC in the sense or alternating current or direct current, whatever the current may be. So we have to transmit. Transmitting means what? Making your current to flow from one end to some another end, which is further place or wherever it is. Okay, so we are making your current to flow from here to there somewhere. Okay, so that is what is called transmitting. Okay, giving out the current to flow. While transmitting DC, there is maximum energy loss. So energy loss or power loss will be maximum when it comes to transmitting your direct current. Okay, so when it comes to transmitting direct current, maximum energy will be lost. Okay, so while transmitting your AC, there will be minimum energy loss. Okay, so very less energy will be lost or power will be lost by transmitting your, what is that? Alternating current. So now looking at this difference, what I can think of. So initially DC is very good, isn't it? It flows in only one direction and its maximum magnitude remains constant. So these are the advantages of DC. When it comes to transmitting your DC, it is not advantageous. AC is advantageous than your DC when it comes to transmitting your signal from one end to another end. So likewise we have advantages and disadvantages too. Okay, here it is disadvantage for your DC, isn't it? While transmitting, it will lose lot of energy. So energy loss will be more or power loss will be more. When it comes to DC, when it comes to AC, there will be minimum, very less power loss will be happening for AC source transmission. Okay, yes. So AC will be very much advantageous here when it comes to transmission of energy or power. Okay, yes. Now coming to fifth point, DC flows in one direction. So we know this, isn't it? So DC flows in only one direction. AC flows in both directions. AC flows in both the directions. Positive direction, negative direction. AC will be flowing. So DC flows in only one direction. This is one of the very important point. Okay, to be written as what difference. Okay. Yes. Now coming to last point. Sixth point is what we will see the examples of DC sources and examples of AC sources. DC sources examples are what? Cells we have, batteries we have. Okay, cells we have batteries. So then we have RPS. RPS means what? Regulated power supply. Regulated power supply. Okay, regulated in the sense regulated in the sense what? Keeping constant output voltage. So that is what is what regulated. A device which will make the output voltage to remain constant. That is what is what regulated. And power supply. Power supply in the sense the device which supplies the power is called power supply. Okay, regulated power supply. The power which will be given out will be what? Constant in magnitude. Okay, so its strength won't change. Such power supplies are called as regulated power supplies and DC generators. The circuits which will generate DC direct current generators are called as what? DC generators will call it as. Okay, so examples of AC are what? AC generators. The circuits which will generate AC current or AC source or AC source generator or alternating current generators are called as AC generators, and we have what we call something called as oscillators. Oscillators are nothing but what signal generators. We call them as what signal generators, or we call them as what alternating current generators. So here we can have different alternating current signals of different frequency we can generate as per our requirements. Such circuits are called as what oscillators. And finally we have what function generators. Function generators are nothing but again your signal generators only. So here in function generator we can have different shape alternating different shape alternating quantities of different frequency are possible. Such thing called as what a function generator. It is an electronic circuit, or you can say it as an electronic device which will make or which will let us to have different alternating signals of different shape, different frequency. Okay, such things are called function generators. These all are the things we will be seeing in our lab. Okay, so we have all these things in our lab, and while doing practical and all, we will be seeing all those things. Okay, so these are the examples of your DC voltage sources, and these are your examples of your AC voltage sources. Okay, so this is how you have to go for your comparison or difference between your AC and DC. So it is very important. You will be getting, you may get either 2-mark question or 3-mark question, or sometimes it is asked for 5 marks too. Okay, so it is very important thing to be known. Okay, so we have to remember it very properly.